Right. So good morning, everyone. So let me share the screen. Yeah. So I think in the previous class, we are discussing about the structural design of pipe culverts, right? So here, the main important parameter where we have to calculate the supporting strength. So supporting strength is basically depends on strength factor and the 3-edge bearing strength, isn't it? So how to calculate this strength factor? Strength factor is always depends on the bedding surface, right? So there are 3 different types of beddings: earth bedding, first class bedding, and concrete cradle bedding. So based on these 3 different types of bedding, your strength factor is defined. Clear? Right. So now next immediately we have to calculate what is this 3-edge bearing strength. So 3-edge bearing strength is depends on 2 main important things. One is weight of filling material. See, whenever you place your pipe as a culvert, so definitely your pipe will be, will be have a lot of, earth fill forces, earth pressure ఉంటుంది. So definitely we have to calculate what is the weight of this filling material on the periphery of the pipe culvert. Okay, so that we have to consider. And the second thing is the surface live load. So definitely on the top of the pipe culvert, so there will be a movement of vehicular movement. So definitely that vehicular live load is also supposed to be considered, right? So that's how your 3-edge bearing strength is going to be calculated, okay, from the factor of safety. So what is the factor of safety? Here we are considering factor of safety as 1.5. Okay, right. So now how to calculate this weight of the filling material and surface live load? So there are 2 empirical formulas. One is CEW d square. So C is nothing but coefficient, W is nothing but density of soil, D is nothing but external diameter of the pipe. So based on this, you are going to calculate the weight of the filling material, right? Clear, guys? And the next one is, surface live load. So here the surface live load you are going to calculate based on the class of vehicle, right? So as I told you, there are different classes of vehicles. Okay, class AA, class 70R, class B, and class A. Okay, based on that, your live load is going to be defined. So in this, your formula is defined as W is equal to 4 CSIP. What is that CS? CS is nothing but influence coefficient. Okay, it's always depends on the diameter and the head. Okay, and I is nothing but impact factor, and P is nothing but the live load which is coming from the vehicle. Okay, so this is how the surface live load is going to be calculated. Clear? Right. So now let's see how this I is going to be, I mean, your what is that CS value is going to be considered. So CS value you are going to get from this influence coefficient table. Okay, so here internal diameter is all given like 500 to 1.2 meter, and a half meter nunchi 1.2 meter dia pipes varaku it was clearly given. For this, your external diameter should be this much. Okay, and these are the height of embankments where you have to follow. Okay, clear, guys? So this is how the CS value is going to be taken. And don't worry, for your exam point of view, CE value and CS value will be clearly given in the problem. Okay, no need to get from any table. Okay, so that's why you no need to get worried. But at least for the knowing purpose, at least know how you are going to get the influence coefficient CS and CE values. Okay, right. And next, let's talk about classification of RCC pipes. Okay, so what do you mean the classification of RCC pipes? How the RCC pipes are going to be classified? Okay, so there will be just concrete pipes. So let's discuss this one by one. So this is the topic. There are 2 more topics left in this pipe culvert, and then we can straight away go to the problem. Okay, right. So let's see what is the classification of RCC pipes. See here, it's all depends on the application. So which type of pipe is to be used for for placing there anedi, it's all depends on the application. So here RCC pipes are categorized as non-pressure and pressure types. Ardhamavutunda? Okay, what do you mean non-pressure and pressure pipes? So you can just place a pipe without having any pressure on its circumference. So ilanti konni pipes untai, and there will be one pipe which is having complete pressure, earth pressure untundi, water pressure untundi. Okay, so like that, there are few pipes which will be considered as a non-pressure pipes, and few pipes they are considered as a pressure pipes. Okay, అందువల్ల RCC pipes are categorized as non-pressure and pressure pipes గా categorize అయి ఉంటుంది. Okay, and coming to the standards of these pipes, so which is given by IS 458 1988. So what this code is talking about? So this code is talking about usually the pipes are going to be, I mean, the diameter and the size, everything. The pipes are going to be categorized under NP3 pipes ka categorized చేస్తారు. Please try to remember, this is very, very important for competition exams. Okay, so your pipe culverts, pipes are going to be categorized under NP3 pipes ka categorized చేస్తారు. Okay, they are generally used for road culverts ku వాడతారు. So I will show you what is the NP3 pipes and how they are categorized. I will show you. And the standard length of these pipes are 2.5 meter. Okay, usually the standard length of RCC pipe will be 2.5 meter. So you can ask me, sir, the road width will be, if it is a 2-lane road, it will be 7.5 meter. Okay, under this, if you want to lay a pipe, if the pipe is only 2.5 meter, how you can cover 7.5? And you have to add, okay, 2-3 pipes here to make, I mean, to cover the whole width of the road. Understand? So these 2 pipes are going to be jointed with the help of a cement mortar. Understand? Okay, so that is the reason why whenever you see the pipe culverts, your pipe won't be just like, you know, the head of the pipe won't be, I mean, to say, the head and the mouth. Okay, mouth around, it will have a huge opening. Okay, and then your pipe will be converged like this, and your pipe will be like that. Ila untundi mee pipe. Understand? So why your pipe is just converged and we having a big mouth? Why? Because if you want to join with another pipe, so definitely this dia can easily fit into the big dia. Yes or no? Avuna? Emma? Kada? Right? So that is the reason why your head of the, I mean, mouth of the pipe will be more in dia up to some extent. Inta varaku untundi. Okay, so by that you can able to fit another pipe just to that. Okay, next to that unko pipe man fit cheyagalugutam. Okay, without having any leakage. Understand? So that is the reason why your pipes will be prepared or casted, okay, in that manner. Okay, so usually the length of the pipe will be 2.5 meter or maximum 3 meter pipes kuda meer chodochu market lo. Okay, so if the overall length required is not a multiple of the standard length, then fractional pipe lengths may be ordered from the manufacturer. What do you mean that? For example, if you need 4 meters exactly, okay, instead of adding 2.5 plus 2.5 making into 5 meters, okay, so which is 1 meter, which is unnecessary, you can order from the industry to get 4 meters exactly. Okay, industry nunchi meeku exact pipe kuda meer order chesukovachu. Okay namma, right? So in that way, so there is a flexibility. So it's all based on the number of quantity you require. Okay, so if you need more quantity, definitely you can order from the manufacturer industry. Okay, so where they will get you the exact size of the pipe required for the placing below the road, below the path, right? So here you can see what are the different types of pipes and their utility. So this is the pipe designation and this is a utility. Utility ante enti? What is meaning of utility? What is meaning of utility? What is the meaning of the utility, Amma? See, at least some should respond, Amma. If no one is responding, I either told you I won't continue the class. Utility ante enti? Purpose. Hello, are you there? మీ అందరికి కనిపిస్తుందా? Students, please respond.
Yes, sir.
Yes, sir.
Voice and video clarity unda?
Yes, sir.
Okay, then fine.
Yes, sir.
So here utility is nothing but purpose. Okay, so let's see, as I told you, these are the four different types of notations: NP1, NP2, NP3, and NP4. The pipes are going to be notated like this. First one is unreinforced concrete non-pressure pipes. And the pipe which don't have any reinforcement inside, which is something like a PCC pipe. Okay, what do you mean PCC? Plain cement concrete. So these pipes are going to be used for drainage and irrigation above ground or in shallow trenches. Shallow trenches and very low depths. Alanti chota they're going to use unreinforced concrete non-pressure pipes in water. Okay, for the drainage purpose and even for the irrigation purpose also. Understand? Second one is reinforced concrete light duty non-pressure pipes. It is nothing but RCC pipe, but the purpose of this pipe is not too heavy. Okay, light duty and takku load carriages, which is a non-pressure pipes. So these are going to be used for drainage and irrigation and for culverts carrying light traffic. Can anyone tell me what do you mean light traffic? Light traffic and I can say the class B loading. And then the road which carries class B loading. So which will be around 35 tons, 40 tons loading unna bridge, unna roads anamata. Okay. So alanti chota we can make use of this reinforced concrete light duty non-pressure pipes. And the next one is reinforced medium duty non-pressure pipes. Okay. For drainage and irrigation and for culverts carrying heavy traffics. Okay, heavy traffics and I can consider 70R, class AA and class A. All these I can consider it as a heavy road traffic vehicles. Okay, so this is how NP3 is majorly used for the roads. Okay, na? So if anyone asks you which type of pipes are going to be used for roads, and you can say reinforced medium duty non-pressure pipes are going to be used for roads, for drainage and irrigation purpose, and for the culverts which can carry heavy roads, heavy traffic, especially for the roads. NP4, which is reinforced heavy duty non-pressure pipes. Again, it can be used for drainage and irrigation use and for culverts carrying heavy traffic, especially for railways. Okay. Even for the railways also there will be a culverts. Kada? Below the railroad, so definitely below the railway track, so there will be a small pipe culverts. Usually, what is the main purpose of providing the culvert, amma? To pass water from one end to other end. Kada? So usual ga, why we want to transfer water from this end to this end? Because usually it is like it's a natural flow of virtue. Not to disturb its natural flow, you are going to have a culvert. One more thing, to pass water from left irrigation area to right irrigation places. Okay, water ni manam pass cheyalanna kuda for the irrigation lands we're going to use. Okay, so that is the way how the different types of pipes are going to be used based on its utility. Clear? Andarki ardhamainda classification of RCC pipes? Guys, clear? Guys, respond. See, at least one or two can respond kada. Unmute chese respond cheyochu ante. మీరు వింటున్నారు లేదు నాకు ఎలా తెలుస్తుంది? It's your wish. And the next one is reinforcement in pipes. Okay, so this is the last topic in pipe culvert. So as I told you, there are RCC pipes which are majorly used for road purpose. Okay, so RCC is nothing but it's a reinforced concrete pipe. So let's see basically how the reinforcement looks in RCC pipe. Okay, so let us take an RCC pipe with a defined thickness. Okay, right? So this is an internal dia, small d, and this is an external dia. Okay, right? And usually pipes will have a longitudinal length. Kada? Yes or no? Right. Now, so the pipes are reinforced with the longitudinal reinforcement and hoop reinforcement. And so definitely pipes will have two types of reinforcement. One is longitudinal reinforcement. And so pipes will have a reinforcement like this. So this reinforcement is called longitudinal reinforcement. What is the purpose of longitudinal reinforcement? Longitudinal reinforcement, it will be like this. What is the purpose of providing a longitudinal reinforcement? Anyone? Pipes లో ఎటువంటి స్ట్రెసెస్ ఉంటాయమ్మా? In pipes మీరు అందరూ strength of materials లో చదువుకున్నారు, thick cylinders, thin cylinders అని. Yes or no? So usually in pipes what type of stresses will develop majorly? In pipes there will be two stresses majorly develops. One is longitudinal stress. For that you are going to provide a longitudinal reinforcement. Other one is hoop, or it can also be called as circumferential stress. Okay, so nothing but the reinforcement which you are providing on its circumference. Kada? So is circumferential reinforcement ela untundi? It will be like this, as a ring. Okay, so we are going to provide rings, right, on its circumference. అర్థమవుతుందా అందరికి? Right? So this is how the circumferential reinforcement is going to be provided to the pipes. Okay, so these reinforcements are designed for the field load. So however, the quantity of the steel used in the pipe for longitudinal and hoop reinforcement should compile based on the code IS 458/1988. So ఈ code చెప్తుంది. Okay, so now let's see what is the spacing of circumferential reinforcement and longitudinal reinforcement is to be provided as per the code. Code ఎంత spacing provide చేయమంటుంది reinforcement అనేది చూద్దాం. Okay, so here you can see three important points. First one, provide 200 mm spacing of circumferential reinforcement. ఏంటి circumferential reinforcement అంటే ring. Okay, so here the ring which is going to be provided to safeguard the circumferential or hoop stresses ni control cheyali ante you have to provide the circumferential reinforcement. So these rings are supposed to be provided with a spacing of enta spacing to provide cheyali ante 200 mm for pipes of nominal diameter 80 to 150 mm. 80 to 150 mm dia unna pipes ki you have to provide spacing of 200 mm. Okay, if the pipes are of diameter 200 to 350 mm, provide spacing of each stirrup of each ring, I can call it as 150 mm. If the pipes are having more dia of 400 mm and above, try to provide spacing of 100 mm. Okay, so like this the spacings are going to be provided. Okay, see, you can see it clearly, dia increases, the spacing of the circumferential reinforcement is decreasing. Avuna? Yes or no? The spacing is decreasing based on the dia of the pipe. Pipe dia eppudaithe perugutundo, so it has to have more circumferential reinforcement. That is the reason why the spacing between two rings, okay, circumferential reinforcements is very less, 100 mm. Okay, please try to remember these three important statements. Okay na? Right, so now let me show you what is the standards for reinforcement for NP3 pipes. Okay, and what are the stresses going to be considered. Okay, another chuddam. So now this is the internal diameter of the pipe, 350, starting with ending with 1200 mm. For this pipe, this is the longitudinal steel with the permissible stress of 0.78. So we can consider this as a permissible stress for steel, and the spiral reinforcement permissible stress is 2.95. So considering this main longitudinal steel as a main reinforcement and considering this spiral reinforcement as a stirrup. Okay, main reinforcement will carry bending or tensile stresses. Okay, and stirrups will carry shear stresses. But usually in pipes, okay, your stirrup, whatever the stirrup you are providing as in a form of a ring, okay, the circumferential stress which develops inside the pipe, either due to water or whatever it is, your circumferential stress will tends to have what type of stress? Em stress ఉంటుంది దీంట్లో tensile stresses ఉంటాయి. Why? Because your circumferential ring will try to expand. Okay, so obviously there will be a tensile stresses develop in a circumferential stress. Okay, so circumferential stress will be in terms of tension. That's what I would like to tell you. Okay, and usually longitudinal reinforcement also will be under tension. Kada? Longitudinal rods also will be under tension, right? And the last one is ultimate three edge bearing strength. So based on the internal diameter, you can straight away even take the ultimate 3 edge bearing strength from the table NP3 pipe, from the table 6.5 values the noise తీసుకోవచ్చు, or else you can able to calculate this ultimate 3 edge bearing strength from the formula also. Avuna? So how can you calculate this ultimate 3 edge bearing strength? So 3 edge bearing strength you can able to calculate even from this formula also. Okay, ee formula nunchi kuda calculate chesukovachu. This will be just 3 edge bearing strength, but from this table you can able to get the ultimate 3 edge bearing strength, just to cross check whether your 3 edge bearing strength is within the limit or not. Based on the diameter of the pipe అనేది చెక్ చేసుకోవాలి అంటే you can make use this table. Okay, reinforcement table ni manam use చేయొచ్చు NP3 pipes as per IS 458 1988 table prakaram. Okay, okay guys, right? So this is the information, brief introduction and clear information about the pipe culverts. Okay, now let's do problem. There are 2 problems in pipe culverts which are very simple. Okay, so by that we can start another topic which is a box culverts. Okay guys, right? So now I request all of you, so please open your notes and note down this problem. Andari problem note cheyandi everyone. Guys, please all of you note down this problem. Here they are asking something to calculate, so let us do this and then we will start doing a complete pipe culvert design. Okay, as a layman, I mean as a designer, from the scratch you can able to design the pipe culvert for any kind of road work. Okay, a roads kaina, I mean for highways, for state highways, even for any type of vehicular loading, you can able to design the pipe culvert. Ela design chestaro kuda chala clear ga explain chestanu. Okay, so first of all note down this problem. So this is a small a kind of gate question ankondi, right? So let's first read out the problem. A pipe whose edge bearing resistance is 43 kilonewton per meter. Okay, so edge bearing resistance already ichar and internal diameter is 600 mm given, is chosen to be used for a culvert. So there is a pipe having an internal diameter 600 mm and the edge bearing resistance is 43 kilonewton per meter. The earth cover on the pipe is 2 meters. Pipe paina enta earth fill ayi undi 2 meters. Okay, earth cover on the pipe is 2 meters. IRC loading, what is the IRC loading which is considering for designing this pipe culvert? Class A. Okay, this is also a given data. Class A vehicle are to be considered for live load. Live load ki consider cheyalante IRC loading is going to be considered as a live load, and this earth cover 2 meter is going to be considered as a earth fill. And then so what is the purpose of having this earth cover on the pipe? To calculate the weight of soil. Okay, So this IRC class A vehicle to calculate the live load. Okay. And as I told you, these coefficients will be given in the problem. CS and CE value clear ga icharu. And the unit weight of soil, nothing but density. And the 1800 kg per meter cube. Nothing but 18 kilonewton per meter cube. Okay. And the choosing bedding of the pipe. Choose the bed of the pipe. And the problem la adugutunnade idi. What is the bedding for the pipe is supposed to be used, okay, for this particular pipe culvert and adugutunnaru. Can anyone tell me, for choosing the bedding for the pipe, what I have to calculate here? In this problem, what they are asking you to calculate and what they are asking you to recommend. So clearly problem is stating for choosing bedding for the pipe. Okay. What I have to calculate here? If I calculate something, then only I can able to know what type of bedding can be recommended. Kada? Em calculate cheste naku type of bedding vastundi. Chapali. Can anyone answer? From this problem, what I have to calculate, and from that only I can able to decide the bedding of the pipe. Em calculate cheyali. Guys, anyone? See, you have to respond. Respond chestara chera. Tell me, em calculate cheste, I can able to choose the bedding of the pipe. Hello? Emma vintunnara vinatledha? Hello? See, you have to calculate the strength factor to know the bedding of the pipe. Because nenu concepts cheptunnapude chupichanu. So there is a clear cut table over here. Type of bedding is always depends on the strength factor. If the strength factor is 2, the bedding is earth bedding. If the strength factor is 2.3, the bedding is first class bedding. If the strength factor is 3.7, the bedding is concrete cradle bedding. Ante, so here in this problem, I have to calculate what is the strength factor. Ona? So in this problem, I have to calculate what is the strength factor. Yes or no? Right? So let's calculate the strength factor by knowing the other parameters. Okay. Right. So first, let me take the attendance. Okay. Right. Yeah. So under vintunara problem. Chestunara andre, have you noted down the problem?
Sir, yes, sir.
Yeah. Right. So let's see. Yeah. So now for choosing the bedding surface, so we have to calculate the strength factor. Okay. So let's do the problem. So simple, amma problems chala easy ga untai. So first of all, here the unknown parameters enti, I have to calculate what is the live load from the vehicle. Idi kaval naku. Right. And the next one, what is the loading from the earth fill? Soil earth fill nunchi loading ento kavali. And this factor of safety, I know 1.5. Don't worry. And strength factor calculate cheyali. And edge bearing strength ఎంత ఇచ్చాడు ఆల్రెడీ, ఎంత edge bearing resistance 43. So this value is already given as 43 kilonewton per meter. So now immediately I have to calculate two things. One, live load. The other one is earth fill. Simple. Formulas already మీకు చెప్పాను. W is equal to 4 into CS into I into P. 4. CS coefficient ఎంతమా 0.022 into I. What is I? I అంటే ఏంటి? What do you mean I? Impact factor. As I told you, impact factor generally we can take value as 1.5. Okay. So impact factor 1.5 తీసుకోవచ్చు straight away. So 1.5 into P. What do you mean P here? P అంటే ఏంటమ్మా? P అంటే ఏంటి? Can anyone tell me what do you mean P? Live load of class A vehicle. అంటే class A vehicle యొక్క load. Okay. So class A vehicle అంటే so every tire will carry a load of 114 kilonewton. Class A loading యొక్క tire load 114 kilonewton ఉంటుంది. అవునా? So if you take road, so this is your pipe culvert. On a pipe culvert, how many tires can place? Any tires నేను place చేయొచ్చమ్మా pipe culvert మీద? Vehicle ki usually it will have 4 tires, right? How many tires can place on a pipe culvert? 1 or 2 or 3 or 4 చెప్పాలి. So let us consider this as a road. Vehicle is moving like this. So this is the pipe culvert. This is the pipe culvert which is placed below the ground, below the road. How many tires I can place on a pipe culvert? Any tires place చేయొచ్చు? చెప్పాలమ్మా. Any tires place చేయొచ్చు? Vehicle will have a length, right? So 2 tires will be outside the culvert and 2 tires will be on the culvert. Understand? So this is how the vehicle can be placed on a road. Okay. So only 2 tires will be placed on a culvert. So that is the reason why every tire will carry a load of 114 kilonewton. 2 tires ante 2 into 114. So this is the load which is acting on the, this is the live load which is acting on the pipe culvert. Understand? So 4 into 0.022 into 1.5 into 2 into 114. What does it mean 2 into 114 ante 2 tires yokka load which is considering as a point load. Okay. From this you can able to calculate the loading on the pipe due to wheel load 30.14 kilonewton per meter. And next immediately calculate load due to the earth fill. This is due to the wheel load and this is due to the earth fill. Formula enti W is equal to CE. This is not capital W, this is a small w. Small w capital D square. Okay. So as I told you, CE value కూడా ఇచ్చారు 2 అని. No worries. Small w. What is small w? Density. ఎంత ఇచ్చారు? 18 kilonewton per meter cube. 18. Okay. And next one capital D. What do you mean capital D? Capital D అంటే ఏంటమ్మా ఇక్కడ? Capital D is nothing but external diameter of the pipe.